The next phase of discussing slope will be to be able to visually recognize whether the slope has a positive slope, a negative slope, whether it's zero or possibly undefined. We can do this by looking at the slope visually. We can also look at the value of the slope to give us some indication of this. And so this concept summary box is very, very important just for your understanding of slope. Now, I will tell you this, from my experience with the ACT and standardized test, if you know these things and can quickly move through these types of identification parts, you can get a lot of questions done a lot quicker than having to actually calculate. And so this will help you eliminate possible wrong choices on the ACT. So this is a good little box to, I don't want to say memorize, but have a good working understanding. Now, let's just take a simple look here. If we're talking about positive slope, we're talking about an m value that's bigger than 0. And so if we read the graph from left to right, you can see that it is rising. And so we like to clarify positive slope as rising. On the opposite side of that, we said that a negative slope is falling. And of course, we're reading this from left to right, similar to a book. Now, horizontal and vertical lines are a little bit more challenging, and I will tell you this, that this is what most standardized testing professionals would consider a test separator. Most students don't learn this well enough, and it separates the scores between the students who have taken the time to learn it and the students who have not. And so if we look at horizontal line, a horizontal line has a slope of 0. I mean, it has no rate of change as you run across a level playing field, so to speak. So if we're running down the street, and there's no incline, there's no slope, it's just a slope of 0. Now, the easy way that I like to remember this is I like to take the horizontal line and I like to make a Z, meaning 0 slope. And that's just kind of my visual way of reminding myself. Now, on the opposite side of this, and by the way, let me just clarify this. On 0 slope, what's going to happen is you're going to actually have a 0 value for your y's over some x value. And if we remember that a 0 is in the numerator, it is simply equal to 0. Now on the flip side of that, we have a vertical line. And a vertical line is a little bit more challenging. And the little visual I give myself is the fact that I say that it has no slope. Now, this is different than 0 slope. What no slope means is it basically is undefined. There is no horizontal change, and so there is no steepness. This would be like jumping off a cliff. There is no gradual downcline. So the way this looks mathematically is that you end up getting some number value for your changes in y's over 0. And if you recall, anything divided by 0 is technically undefined. And so a vertical line always has some undefined slope. So this is a very good concept summary. This is extremely important for you to know and can be very beneficial to you not only in Algebra 2 and for the linear functions unit, but this is tested quite often on standardized tests. So let's take a look at an example of how we could ask you to do this mathematically. It says, without graphing, tell whether the line rises, falls, is horizontal or vertical. So we would first have to find the slope of the individual lines. So understanding the slope formula is important. And then we would have to determine how that slope value fits into our concept summary. And so you can see in part A, we had a positive slope, and so that means the line is going to be rising. In part B, we had a number over 0, which means that this is undefined, which makes the line vertical. So let's go to sample problem number 2 here. In sample problem number 2, we ask you to do the same thing. So using the example above as your guide, go ahead and pause the video and work the 2 parts of the sample. Okay, for part A, first things first, we need to find the slope of the line. And of course, that's going to give me a slope of 0. And remember, if we have a slope of 0, we have a horizontal have a horizontal line, and of course visually that looks like that. For part B, the fact that we have a slope of negative 2/5. The 2/5 right now is unimportant. We'll get to that at a later point in time, but what we're more concerned about is the fact that it's a negative sloping value. And so if it's negative, it's less than 0, so that means it falls from left to right. So it would have a general shape that looked like that. Okay, now we can also talk about the steepness, if you will, of slope. And then we have this little grid here that kind of shows us whether it's positive or negative, just how the slope changes the steepness of a given line. And so I'll just use the positive sloping ones. So you can see here this main line here, and we recognize that this is actually f of x equals x. So that's our parent function for a line as we go through there. And you can see that as the slope increases, this actually tends to get a little steeper, and of course as it decreases, it would get what we would consider a little flatter. Now we'll talk a little bit more detail about compression and stretching or dilations as we go through this unit, but that is in essence what's taking place there. So take a little closer look at this paragraph and these sets of graphs, and so you can get a better visual idea of steepness of slope. Okay, that wraps up our visual about rising and falling in horizontal and vertical.